In this video, we're going to look at how to build this, a lifting robot that will fight in the 150 gram weight class in Australia or in America. It may not work for the UK because it may not fit the 4-inch cube rule that the UK runs. This is a fairly straightforward build that has been designed to be as low on tool use as possible to make it a kind of easy first step into the sport of combat robots. Before we look at tools though, we're going to look at this, transmitters. All combat robots are effectively weaponized RC cars, and so this is the thing that we're going to use to control the robot. There are many different options for transmitters out in the world right now. A lot of people use this particular model. It is a FlySky FSI-6. They're fairly affordable, they have a good number of features, and most importantly, they have receivers, as in the electronics that go in the combat robot, that are small enough to make 150 gram robots possible. There are certainly controllers that are better than these, however, these are a really good entry into the sport. And a lot of people use these for a very long time. They are the largest startup cost associated with getting into combat robots, but if you intend to stick into the sport, one of these is going to last you years and years and years and many robots. Even though they are entry level, there is still some setup that you need to do on these particular controllers. In particular, you need to mix your driving stick, which means to take the signals that would normally go only to one channel and convert it into signals that go to 2 channels when you move around your driving stick. That is a little bit beyond the scope of this video, but I do personally have a video on my own channel, Team Panic, that has a full rundown of how to mix it using the screen and buttons shown down here. We will leave a link to that video in the description down below. From this point on, I'm going to assume you have one of these and also have it mixed, because the build that we're about to do uses electronics that are only compatible with the FSI-6, so you will need a controller like this one to continue forwards. So let's take a look at all the electronics and hardware that we need to build this robot. So starting off with our power source, this is a 9-volt lithium rechargeable battery, which while a bit heavy gives the right battery voltage and also means that you can just charge it with a USB plug and don't need to worry about a LiPo battery charger. To add to that, in our power section, we have an LED with a resistor in it. We don't actually need the resistor in it because our control board has one too, but this one does, so we're going to use it. We have a 9-volt battery clip, a power switch, the Llama Forge and control board, a high gear ratio N20 brushed motor, 6 male to female Dupont or Arduino connection cables. These aren't strictly necessary, but we're going to use them to connect the motors to the main control board so that we can easily swap the polarity of the motors without having to resolder everything. 2 34mm wheels, 2 50-to-1 N20 brushed gear motors. These are going to be our drive. And then some screws. So we have 8 M3 10mm long bolts, 4 M3 15mm long bolts, 2 M2 by 5mm long bolts, and 4 M3 hexagonal nylon standoffs, which is all the hardware and electronics for this particular robot build. So let's take a look at the printed parts. These are our printed parts, and as with all of the hardware and electronics, there will be links in the description down below to where to find the STLs for these printed parts. I have printed all of these in my standard strength level printing, which is 3 walls, 3 top and bottom layers, and 35% infill. I also recommend you print these in ABS plastic. It is a more resilient plastic than PLA or PETG. It is also lighter and means that you can actually make weight with this robot. A PLA or PETG chassis may not make weight with all of the components we're putting into this robot. To go over our component selection, we have a chassis, a lid, 2 drive motor mounts, a lifter motor mount, a lifter arm, and lifter forks. I would recommend printing multiple copies of the lifter arm and the lifter forks. They are most likely to be damaged in a fight, and also given the way that this lifter works, it is possible to round out the connection point. So having a spare or multiple spares on hand to be able to quickly swap them in and out is going to be very helpful at a tournament. It is now time to talk about wiring, and thankfully the LlamaForge control board does make this a lot easier. Also, a big thank you to LlamaForge for providing us a couple of control boards to give out at our Science Alive giveaway. Before we start wiring things into this board though, we have some preparation that we need to do, because at the moment the board does not fit into our chassis basically at all. I mean, it does, but in a very awkward state. Thankfully, most of this board is not actually needed. There are some score lines across the entire board, and all we need to do is snap this gently by hand. All you need to do, pinch on either side of a score line and bend apart, and the board snaps. And we just need to do this 4 times to get the excess off every edge of the board. Now, when you get down to the actual control board itself and these 2 additional fins, be careful where you place your fingers. You don't want to remove a component accidentally. It's probably better to grab a section that doesn't have any component and just be very gentle with how you remove the final outer pieces to get down to the LlamaForge control board. So as mentioned, the LlamaForge control board does help us out quite a lot here. Up the top, we have a legend of where things need to be wired up, and down the bottom we have color coding which matches the legend at the top. The only thing that is missing is the LED port on the far edge in purple. Does not exist in the legend at the top. However, if you've got an LED with a resistor in it like mine, we're going to solder it into the dark blue pads, making sure that red goes to positive and black goes to negative. If you don't have an LED with a resistor in it, I need to solder an LED directly into this board and use the onboard current limiting resistor. You solder it into the dark purple. On the back of the board, it shows you which one is positive and negative, and you need to make sure that you get the LED in around the correct way. Continuing through the components that we have, looking at the battery connector, this goes below in the light blue section, again making sure that red goes to positive and black goes to negative. Then we have the switch, which goes into the green connection. And here there is no polarity. The only thing we need to make sure of is that in a switch like this one that has 3 distinct poles, we need the middle connected to one side of the switch and one edge connected to the other port on the switch. And the final port needs to do nothing. That will be the spot where the switch rests when it is off. So currently, if we wanted this position of the switch to be off, we do not connect these front pins to the board at all. We connect the middle and the back pins. But I'll show you this when we get to actually soldering. Our final connections to make here are yellow, orange, and red. Yellow is for the left-hand side drive, orange is for the right-hand side drive, and red is for the weapon. In our case, that is a lifter. And to these, we're going to solder our DuPont or Arduino connectors rather than soldering them directly to the motor, so that if we get something wrong, we can very easily and quickly swap them around and make the robot move in the right direction. The first step for soldering up is to prepare our wires, and to do that we are going to need the chassis, or at least I find it's easiest to do with the chassis, because here we can place in some of our components, so our drive motors, our control board, our switch which goes in the side here, our LED which is going to sit out the back, and of course we need to make sure our battery goes in as well, and that's probably best to sit up the front like this. And just by doing this, we can immediately see that this LED cable is far too long. As you can see, I've got a ton of leftover wire here, and this is actually good because we can use some of this leftover wire for the switch in a second here. So the first thing I want to do is I want to cut down this wire for the LED. Now, effectively, all I'm going to do is try and hold the LED roughly where I want it to be, and then line up some cable right down in the base here to get an approximation of how much cable I want here. And once I've done that, I'm going to give it a little bit more, just for some space to actually solder the wire together, and also just a little bit of wiggle room and flexibility. You don't want your wires to be exactly the length you need them to be, because if you mess up anywhere, then your electronics will not fit into your robot, and you can always pack the wiring down in a little bit with the lid and things as you need to. So in fact, I might even give myself just a little bit more than that. So now I've got an LED wire that is this long. And so all I'm going to do here is I'm going to take my side cutters and I'm going to cut both wires at the same time, snip, And there we go. That is the LED wire done and dusted. As mentioned, we have these leftover pieces of wire and they can be for the switch. The switch is going to be a similar length to the LED wires. So again, I'm just going to measure this off the LED by holding all of the wires together and then finding the point where those 4 wires are at the same size. And then I'm just going to snip these other 2. So there we go, that's our LED and our switch wires all done and dusted. I'm gonna pull the switch out and leave that there so we know what that is for. The next thing to look at is these, the Arduino/Dupont connectors we're going to use for the drive and weapon motor. When I'm setting up mine, I usually use the female side for the motors and then the male side for the board itself. This is a personal preference thing. As long as you do the same thing everywhere, you should be fine either way around. Also, we don't need a lot here, and these plugs themselves are actually kind of large. Well, they are large for a robot this small. Rather than cut this in the middle and use half for the board and half for the motors, I'm gonna go a little bit closer to the edge on both sides and use those as my wires. Now again, I'm gonna use my lining up trick from before, so I'm lining things up and making sure I cut in the same spot. So now I've got a group of 6 wires which will be connected to the backs of my drive and lifter motors. And I'm gonna cut the other sides basically in exactly the same way, line things up and just snip. The way these come, they are glued together in their little strips, and we can fix that. Once we've cut them down to our desired length, we can fix that by simply peeling them apart. And we will need to do this anyway. Personally, I prefer to keep wire colors together, so I will wire up all the greens and all the blues and all the purples to the same thing, especially on the motors. I will have a green motor, a blue motor, and a purple motor with my current wire selection. The actual color doesn't matter too much, it's just a kind of reference to yourself that these wires come from the same motor. Or if you're looking at them from the control board side, it means that these wires come from the same control signal set. So for the left-hand motor and the right-hand motor and the lifter. Our final wire to prep here is of course the battery connector. This battery connector needs to sit on the battery itself and wrap all the way down. So this is probably going to be a little bit of a longer one. I've added a little bit extra to this already, but I'm going to give myself just that little bit more. Once again, just because it's better to have a little bit more wire you can cut out later than to not have enough. And that gets me my wire length for my 9-volt battery. Having cut the ends down, we now need to expose some wire so that we can solder to it. As mentioned at the start of this video, the easiest way to do that is with a set of wire strippers like these. Wire strippers are fairly straightforward. They have a grab jaw on one side and a cut jaw on the other side. You simply place the wire in with a small amount over the cut jaw and then squeeze. And when you squeeze, the wire strippers grab on the grab side and cut with the cut side and then pull apart, creating a small exposed section of wire like this. You really don't need a whole lot. I could probably strip just a little bit more wire off of this. And in fact, I will, just to make it a little bit easier on me. As mentioned, wire strippers aren't the only way to do this though. These side cutters that you used before to cut the wire down can also be used to strip wire, but this is a more difficult process because you want to get the wire into the jaws, push just a little bit, but not enough to cut all the way through, and then pull. And in doing so, you will also strip the wire, but you get less control over this, and it's very, very easy to cut the wire entirely off by doing it this way. If you're going to be doing more than one robot, you're going to be doing a lot of wiring. It makes a lot of sense personally to buy yourself a pair of wire strippers. And I do not ever use this method anymore. I did when I was a uni student, but I no longer do that. I will always use wire strippers to strip my wires. And that's our 9-volt battery lead wire stripped. So we now need to strip all the rest of these wires, which is why I said that if you're doing more than one of these, having a pair of wire strippers is invaluable, because already this is going to be a decent amount of wire stripping that would be somewhat painful without a pair of wire strippers. Once we've stripped all of our wires and made some rainbow confetti, we are very, very close to finishing the prep on these wires. The next step is to tin these wires, which means to coat all of the newly exposed wire in solder. Which of course means it's time to get out our soldering iron and our helping hands. As mentioned at the start of the video, while helping hands are not 100% necessary, they help a whole lot and will also avoid you burning either your own hands or somebody else's hands, whoever is holding the wire that you're trying to solder together. Especially as we are soldering quite small things, you will have to be holding things quite close together. It's very, very easy to burn somebody with a 300+ degree soldering iron if you're not using helping hands. These are just alligator clips that hold your wires for you when you're trying to solder things together. One final tip I'm going to give here is that as you go to tin each of the wires that you have cut, grab the actual wire itself and give a bit of a twist. This is because most wire is multi-strand wire, and by giving a bit of a twist, you kind of twist the strands around themselves and stop any stragglers from kind of fraying out from the bunch, which will cause a big blob of solder and a very wide solder joint, which could cause you issues trying to get wires into boards or connected to other wires. So tinning itself as a process is fairly easy. First, we get our soldering iron over here hot. We are then going to touch some solder to it, get a little bit of a blob on there, and just clean it off is probably the easiest first step. That can be done into brass wool or into a slightly damp sponge. It just cleans up the tip of the soldering iron. Make sure that you're getting good solder contact to it. Once you've done that, add a little bit more solder to the soldering iron, and then all we're going to do is we're going to bring this into contact, that blob of solder into contact with the wire, and apply solder from the other side as well. If you get it right, the solder should adhere to the wire and the wire should go the nice silver shiny color that the solder is. This is pretty important, so I'm going to do another one of these on camera just to show you how it's done again. So again, I'm going to put a little bit of solder on my soldering iron. I'm then going to clean the tip of the soldering iron. I'm then going to put a little bit more solder on the tip of the soldering iron, place it on one side of the wire, place the solder on the other side of the wire, and let the solder flow. A nice shiny tinned wire. Of course, it is now time to go through and tin all of our wires so that all of them have a nice coating of solder on them before we get soldering. This will help with making the connection stronger and faster in the next step. With the wires tinned, it is now time to actually start soldering bits together. So we're going to start with the drive motor because these are an easy thing to do early and they give us a little bit of practice at soldering before we get in and have to solder things that are really, really close together. So the way I like to do this is, again, in the helping hands, I put the shaft of the motor in one clip, and then on the other side, I am going to put my wire. So again, I'm going to use the female side of this connection for my motor, and all I'm going to do is line up the tinned portion of this wire with the contact on the back of the motor. Personally, the easiest way I find to do this is to get it close, clip it into the alligator clip, and then either bend the wire itself or move the alligator clips until everything lines up. Now, they're not fully secure in that front jaw, so I could probably change the angle of this shaft to make that a little bit more secure. But for right now, I have done what I needed to do, which is to get the wire lined up with this contact. With that done, it is a fairly similar process to what we've done before. Having already cleaned my soldering iron, I'm going to put some solder on it. I'm going to go from the underside with my soldering iron and then the overside with the solder until the two flow, and I have bumped the wire. You can see the wire did not connect. So I bumped the wire when I was trying to move around my camera and things did not connect together. So that's fine that there's a little blob of solder on there still. I'm just going to clean my soldering iron again. In fact, this blob of solder that's already on there should make this a little bit easier because we don't actually need to add any more solder to this joint now. We should just be able to touch the two together with the soldering iron or with a blob of solder on the soldering iron and have that connection joined. A good way to know if you have made a proper connection or not is to let go with one of your alligator clips and the joint should hold. If you really want to be sure, you can tug on it. Because you have fused this wire to that connection on the back of the motor with molten metal, you should not be able to break it by pulling straight back. Try not to wobble back and forth too much. That could potentially cause wire fatigue and cause a break that way, but pulling straight back, like so, should keep the joint together. And if it does, then you have successfully soldered your wire to your connection. If it does break, don't worry. Depending on if there is wire left, you may need to re-strip and re-tin your wire, but then push it back together, hold it together, add some more solder this time, maybe leave a little bit more heat on it, make sure everything flows nicely before you release the heat, and you should have a good solder joint. With one done, it is time to flip the motor on its output shaft and do this whole thing again. As mentioned, I like to try and keep the two wires be the same color each time, so I am going to set this up to run a second blue wire into this motor. While I solder this up, I'll also mention that you can, of course, use the holes in the motor connection tabs to feed the wire through. Personally, I do not do this because it makes unsoldering those wires a lot harder if you ever get to the point where you want that wire to come back out again. If the wire is held just with the blob of solder, heating up the blob of solder will release the wire and it will come back out. If it is threaded through that hole, you will need to heat it up and wriggle it to get it back out, which can be quite problematic. And there we go. We now have one of our two drive motors soldered. So I'm just going to repeat this process for the other motor. The lifter motor I'm using came supplied with wires on it, so I'm going to do a slightly different process here. As you can see, I have tinned these wires out already, and I have cut my other wires a little bit shorter because I don't need the wire length because the wire length is already on the motor. So we're just going to connect those two wires together. And the easiest way to do that, again, is to put things in the alligator clips. So here you see I've held the two wires in the alligator clips. I often find that with alligator clips and helping hand setups like this, it's easier to have the two effectively perpendicular to each other to get wires to mesh correctly down the bottom. Just because of the way that the geometry works with the arm, it's easier to get wires closer together like this. Now my wires may look pretty good here, but they're actually not touching in the three-dimensional view that I can see that the camera does not pick up. So I'm just going to push down on this green wire a little bit, make sure that they are gonna touch. There we go. So those two are now 100% touching. And again, we're gonna do the same thing we've done a number of times here, which is to clean the soldering iron, add a little bit of solder to the soldering iron, and then from two directions, the soldering iron underneath, the solder on top, we're gonna flow some solder together, make a little blob. Probably a little bit too blobby, but that should actually work pretty well. Soldering is a fairly straightforward process. The biggest thing is making sure you've got heat all the way through the joint. And the best way to do that is to have a little bit of solder on the soldering iron when you start. That causes effective heat transfer into your wires. And then pushing the solder from the other direction means that this solder that you're adding doesn't start flowing until heat is all the way through the joint. And then when that happens, the solder basically flows back down through to the soldering iron, coating everything all at once. Which is often the problem people first encounter with soldering, is they don't put enough heat into their solder joints, only one of the wires gets hot and molten solder flows into one of the wires, but not into the other one. The other thing here is that because we have pre-tinned our wires, the wires are a lot easier to heat up and are a lot more accepting of solder, which makes this whole process a whole lot easier. Obviously, this is one of two for this particular motor, but I'm going to do the other one off camera because it is a repeat procedure. The one thing I'll mention about our now soldered motors is that all of them have some exposed contacts on them. The ones where the cable is soldered directly into the motor have exposed balls of solder down the end right near where the motor is, which aren't going to be too much of a problem, but could still potentially short out if something big and metal comes across and hits across them. And then the one where we've soldered wires together, we've got blobs of solder that are floating around. These are much more at risk of shorting out because they can actually at least like touch each other, which is a big problem. But we are going to use hot glue to solve this problem in a minute. But we're going to do that with basically all of our exposed solder joints. So we're going to do that after we've finished soldering the rest of the board together. Speaking of, it is almost that time, but there is one final component to attach wires to, and that is the switch. This is going to be very, very similar to the motors. The only thing that is slightly different here is these pins. In some cases, these pins are not connected across in pairs. And so if you soldered to one side in the middle and then the other side at the output, you actually wouldn't get any switching action happening at all. So to fix this problem, we're going to pinch these together with our pair of pliers, and then we're going to solder across them so that both sides get connected to the board. And this way, we double the current carrying capacity of our switch, and we also make sure that we don't mess up and wire up a switch that doesn't actually work. That's kind of what it should look like. So with them bent, this is a very similar process to the motors. We're just pushing the wire and the contacts together, and then we are heating up some solder, putting the solder into the joint, and just flowing a ton of solder in there. Now, if you haven't bent these down enough, you may need to flow a lot of solder to get the two of them to come together, and you may even need to flow solder from the top and the bottom to get the two contacts to fuse, but it shouldn't take too long and you will get that going. Again, remembering that with soldering, everything is about getting enough heat into the joint to have solder flow everywhere. If you see the solder liquid at the top and not at the bottom, you haven't got enough heat. Either turn your soldering iron up or leave the heat on a little bit longer to allow that heat to flow through the joint and make sure that the solder connects everywhere. And again, in parallel to the motors, we just need to do this twice to get the switch all together. And again, it's as simple as connecting everything into the alligator clips, moving the alligator clips until things line up where you want them to be, and flowing the solder in place. Again, with this switch, we'll be applying hot glue to this later to make sure that the contacts can't be touched by anything inside the robot, and also to kind of shore up these wires to make sure they don't break on us, which is what the hot glue is going to do everywhere else as well. To complete our soldering, it is time for 12 wires to connect into this tiny little board. So some planning is always a good thing. I am right-handed, so I'm going to be trying to come from this direction. So the worst thing for me to do would be to solder the rightmost contacts first, because then they're going to be in my way as I try and solder across the board. Of course, I can flip the board around and I can go this way if I really want to start with the weapon motor, which I might actually do. The other thing to look at is work holding on this. This is a flat board with a lot of little components on it. We don't want to put the alligator clip onto any of those components for fear of breaking them off. So there's only a few spaces that we can actually work hold this particular board. We can either hold it along the row, which is possible when we're soldering at one end. We can hold the other end with an alligator clip. Then there's some small spaces over here where there's nothing, and then there's the section across the top where there's nothing. Across the top is definitely the easiest way to avoid any potential components, but it does mean that you're further away between where you're clamping it and where you're holding your wires. The other thing here is I want all of these wires going up this way towards the camera, which means that I want to feed the wires in through the top and then solder them underneath. And I'm going to show you a really easy trick to get this to work. So I'm going to flip this around the other way. This is the way I want to be soldering. I want to have the solder joints on this side. Let's zoom out a little. So this is the board in our helping hands. Now, if I wanted to try and put this motor wire, this lifter motor wire, into this board at this particular point, I would need to kind of blindly guess from the underside until I manage to poke it through, and then I have to hold it there and wrangle it until I can get the clip on it, and then as long as it stays, I can solder it together. That is very difficult to do. So what I'm going to do is, instead of that, I'm going to show you. So these helping hands, the other reason I quite like these is they have a lot of adjustment potential. So I've got this board this way. I can then grab hold of this bar and spin it like so. Now I've got the board the right way up, and I can very, very easily drop my wire into the hole I want it to go in. Gravity does most of the work of keeping it there. I can just like balance it attach the other clip, and there we go. It is now actually in that hole it's supposed to be in. That was a whole lot easier. And then again, all I need to do, grab the bar, spin it over, and now have access to it from this side to solder it down. So despite the fact that we are now effectively soldering a wire to a flat disc of metal, this is a very, very similar process. Again, I'm gonna clean my soldering iron by just putting a little bit of solder on and cleaning that off in my little sponge. Then I'm gonna put a little bit more solder on, gonna contact that down to the contact down here, apply solder from the other direction, wait for it to wick up, and there we go. One solder joint. These can be fairly fast to do. The trick here is to make sure that you are very precise with where your soldering iron is going and work them in a methodical pattern so that you don't accidentally join two things together. This is partly why I said I didn't want to start from this side and solder back this way, because it's very easy if I've got a solder joint here already to heat both the weapon and the right motor solder joint together at the same time, and then solder flows across the gap between them, and then everything doesn't work anymore. So let's do one more of these really quickly. So again, I'm gonna flip the board over. I can release this clip now because that wire is soldered in place. Then all we do is we add the next wire in. Again, it's a fairly simple process. We're just pushing that wire in, getting our clip on it, or even getting our clip on it first and then maneuvering it in, which is easy to do when you can see the hole from this side of the board, and flip it back around. Now this time I'm coming at this joint from a different direction. This just means that my soldering iron is going to be nowhere near the old solder joint, which means I have less chance of soldering the old one together. And you can see all the solder on that pad flowed together very nicely. I haven't got a big blob of solder and it's kind of wicked up the actual wire here. This is what we want to see. From here on out, this board is effectively practiced. You now need to do that 12 more times. The only thing I will say here is that the negative connections can sometimes be a little bit more difficult on a board like this. This is because what we're trying to do here is we're trying to heat the wire and the little solder pad or the little pad on the board so that the solder heats up and flows between the two of them. On most electronics boards like this, they will have a very, very large negative plane on the board for various reasons that aren't covered in the scope of this video. But that means when you are trying to heat up a negative pad or a thing that is labeled as a negative pad, it could be that you're trying to heat up a huge negative patch of copper on the board. So it can take a little bit longer and a little bit more heat to get the negative pads to flow properly when you try and solder those together. So I'm going to solder in all of my motor connectors and my switch, and then we'll have a look at these negative pads. So these are all soldered up the same way. The only thing you can see here is that I've got bridging between my battery positive and my switch, or one side of my switch, and then the ESC, or in our case, LED positive, and one side of my switch. But that is fine, because in this particular board, those two things have an exposed run of copper between them, just like the negative of the ESC or the LED, which is what I'm about to solder, has with the negative of the battery. So that means that these things are connected by the board, which means that we can run solder between them, and that's fine. As mentioned, this is the negative of the ESC, which means that it could take a second, and it is taking a second. The solder is not flowing as well into this joint because there is more copper that I'm trying to heat up for this particular joint. So I need to hold this a lot longer before it actually finally flows, and I can put a bit of solder into it, and it's kind of stuck my soldering iron there. But it took a lot longer there to actually get that to work. So I'm also going to do that again for the battery negative, so you can see that it takes more time for this particular joint, and it is because it is the negative contact. And once soldered up, you can see we've got kind of a little forest of wires here where we've got some leftover wire in each of these. The best thing to do is to cut these down with a pair of side cutters. However, these are going to go flying when you do that. So make sure you put on some safety glasses, and it's best to aim them into the table like this. All I'm going to do is I've got my safety glasses on, I'm going to find a wire I want to cut down. I want to cut it down fairly close to the actual blob of solder itself. I'm going to flip the whole board over and cut. And normally it will go flying. As you can see, it's not on the table here because it actually hit my wall over that way. Don't do this in a carpeted room because you are going to have tiny little metal filings everywhere after this step. So I'm just going to keep cutting these down because we need to cut down all of them, or at least it's good to cut down all of them so that they take up less room in the robot. Once trimmed, we're going to hit all of this with some hot glue, and literally this is just to protect your own robot from shorting itself out. All I'm doing is just putting a fairly liberal amount of hot glue on each and every one just to make sure it is all covered up, just like that. If you wanted to go further with this, you could then also turn it over and hot glue the giant mass of wires coming out here. This just gives a little bit of strain relief on all of these cables. It does make it more difficult to change wiring later on, so I'm not going to do that myself. This will survive for a little while at least. Not doing this does mean that yes, you will have to potentially redo this and you may break cables down here depending on how tightly you pack your robot. But again, doing it means that it's harder to change these wires over. Of course, we do need to add some hot glue to our switch to protect these two actual live connections over here. We can put hot glue on this final one. It doesn't really matter too much. But what we want to do is make sure we get hot glue on both sides of the contacts to make sure that there is nothing here that can be shorted out. Also, of course, this is a switch. It has a moving component in the middle. Make sure you don't glue the sides together so that you can't actually switch the switch anymore. So this is our wiring mostly done. The final thing is to hot glue our motors as well. And this is the same type of thing. You add some hot glue down to the solder joint that you created. For motors, I also add a little bit up the wire. This just gives a little bit of strain relief to each of the wires and make sure they don't break quite as easily. For the lifter motor that has these splice wires, again, we're just doing the same thing, putting hot glue everywhere there is exposed solder and flipping them all over to make sure that we get both sides and that we don't have any exposed solder, like so. Working with hot glue, you may get a little strand, but that's fine. You should be able to break that fairly easily and just pluck off any of the littler strands that are around the place. This is a little bit messy, but it will do the job. With the wiring done, we have one last thing to do before final assembly, and that is prep these wheels. These wheels are really good. They are a silicon tire around a hard ABS inner. Unfortunately, they are only held together with friction. I can very, very easily push this tire off this wheel by hand. And if you can do it by hand, it will happen in a fight, which means that you will get either the wheel come off completely and you will have no traction and won't be able to drive, or in the worst case, you have something like this happen, where the wheel comes off partially, rubs against the chassis and forces the wheel to stop turning. It jams everything up and just does not work. The easy solution to this is glue, and specifically this glue. It is the red and black cheap super glue from Bunnings. For whatever reason, it sticks the best to plastics and rubbers that you'll find in this kind of wheel. Doing this is really simple. You don't actually need all that much. We are just trying to keep this together. So personally, I aim just for a dab at each of the spokes of the wheel. So I pull back the wheel to expose the inner section. I add a tiny dab of super glue in here. If you really want to, if you're really keen, you can scuff up this shiny plastic with anything you like just to make the glue bond a little bit better. But again, I find I don't actually need to do that fairly often. And then I pull the tire back over into place and just let it sit for half a second so that that glue has time to bond up. And then I will go to the next spoke, expose the inner, add a dab of glue, pull that back over top, rinse and repeat. Don't worry too much about the glue getting in these seams. That should be fine. It will dry out there. It will just dry a little bit slower. And at the end of the day, it'll add an extra little bit of grip to help the tire stay on the wheel. And so we're going to do this final one here. The other reason I only do 3 of these and I only do small patches is because as you go, it gets harder and harder to take the tire off. as there is more tire gripped to the wheel, which means you have less of the tire you can leverage off to expose the inner hub. But there we go, that is one wheel complete, and doing the second one is the exact same process. It is now time for the final assembly, and mostly what we're going to need here is our screwdrivers and our pliers. I'm going to remove the lid and the weapon mounting pieces just for now to make a little bit of room on this cutting mat, and we're going to start with the chassis. So the chassis itself, you'll see on the side, has some features in it. This one is the LED hole, and on the other side of the chassis, we have the switch position. So this is going to be the back of the robot, where those two connect to the back wall. This is the back. So knowing that, we now know that this is the left-hand side of the robot and this is the right-hand side of the robot. So as mentioned, the color doesn't necessarily matter here, but I did set it up so that blue goes to the left-hand side of the robot and purple goes to the right-hand side on my control board here. So I'm gonna try and do the same thing with this. So that means I wanna take the motor with the blue pins, take a motor mount, which has some locating features in it, and put that onto the motor like so. The motor then slots down into this position. But of course, it's not going to stay there. So we need to connect it using one of the longer 15mm M3 bolts and one of our hex nuts. So the easiest way to do this, I find, is to push down on the motor with a finger, turn the whole system over, put the bolt through. Now, you see, I missed, so I can just lift up this whole thing and put that over like so. I can then grab that nut and I can put it down and I can finger tighten it just by grabbing and twisting the nut. Now, once I've got it a little bit engaged, it's not gonna come off, so I wanna do the other one before I tighten everything up. So again, a 15mm long M3 bolt. Again, it is going in through this bottom hole. This time I need to be careful to make sure everything lines up before I push it through. Push it through. And again, we're going to put on a hex nut and finger tighten that down. And we're actually going to go a lot further this time. We're going to finger tighten these both down to the point that we cannot finger tighten them anymore. And once we're here, we need to tighten these even further so that the motor definitely doesn't go anywhere. And the easiest way to do that is with the pliers and a screwdriver. So with the pliers, grab one of the nuts, turn the whole chassis so that you can expose the bottom, grab your screwdriver, and then just tighten. Until you can't get it to tighten anymore. And we're going to do that on both of them. This process, of course, is then repeated on the other side. With these motors in, we can start to connect up our electronics. So I'm going to start by plugging in both of those motors, which again is going to be fairly easy for me because I've set this up to be purple to purple and blue to blue. But even if the colors don't match exactly, just make sure that you're plugging the left motor into the left connections and the right motor into the right connections, and everything will work out just fine. This is also partly why we glue the motor connections, is because we have to bend these wires around quite a lot, and it is fairly easy to fatigue and break them if you haven't glued them to the motor. Now, the other thing I can say here is a tiny screwdriver does help, because this wire was caught under the other motor, and I've just fished that out with a screwdriver. Much, much easier than if I tried to fish it out with my fingers, because the gap it was in was far too small for that. Once we've got those connected up, the next thing to look at is connecting up the power and the rest of this system here. So this battery can really only sit up the front here between the two motor connectors like this. And probably the easiest thing to do is to route this wire underneath the motor wires. So that's what I'm going to do. I'm going to route that wire underneath the motor wires. And as you can see, as we start to do this, the board is going to move around, and it's going to end up really only being able to sit down in one spot. And where exactly that ends up doesn't matter too much, but it will be purely dependent on your wire and how much length of wire you've got and how bendable all of your wire is. So we're going to push this guy down into here. Now, this particular 9-volt cord, actually I want to do the other way around. I want it that way so that the lid pushes down on that connection, and that should be fine. So now we're actually almost there. The next thing to do is to get this switch into place, which again, I just need to think about where I want this board to go. So I'm gonna try and push this board down to basically where I want it, which is down the bottom, down in there. And that's going to push these cables around a little bit, and cable tension should basically hold them in place. Now, looking at this, I can see that these motor wires are arching up and over, so I actually want the switch to be underneath them because that's going to make life a little bit easier. So I'm going to push the switch in underneath them and over like this. At this point, there is an interesting question to ask: which way round you mount the switch in. Personally, I like to mount it so that the off position is up. That way, if there's something that hits down, it's not going to be able to turn the robot off very easily. So that's what I'm going to do. The robot is currently off, so I'm going to put the switch in so that the off position is up. This is a personal preference thing. It doesn't really matter either way. As far as I know, not many people have ever lost from having their switch turned off in this particular manner. So we're going to take our small screwdriver and we're just going to drive these tiny little M2 bolts in to hold that switch in. Now, as before, we don't want to go all the way down yet. We want to get both screws in before we tighten everything down, just to make sure it all holds. But by lining things up, you should be able to get both screws in, and then we're just going to tighten until it won't tighten anymore, and that will hold our switch in place, just like that. So we are now getting pretty close, but of course we have this LED to deal with. So again, this LED goes out over this side. It's probably just going to need to be glued into place. I think the chassis was designed with a slightly smaller LED, but that is fine. All we need to do, or all I'm going to do, is going to take my hot glue gun. I'm going to apply a little bit of hot glue to the LED itself, and then I'm going to hold it nearby that hole so that when the LED turns on, it's going to shine light out through this hole. And because all we really need this LED to do is be an indicator. Now, this has meant that the wires are poking up a little bit, so I'm just going to bend those down. They should be fine to sit down like that. And now we are very, very close to actually completing this build. But before we get to the weapon system, we're going to make sure the electronics are connected correctly and the wheels drive correctly. We're also going to bind everything and just get it all sorted before we put the lid on, because it's a lot easier to do at this stage. So the first thing I'm going to do is put my robot up on something. This can be anything, a roll of tape. I'm using a roll of solder, basically just getting it up off the ground so nothing contacts while we're doing our electrical testing here. We're also going to need to bind it to our transmitter. When we power this up for the first time, the board is going to look for a bind. There's another way to put it into bind mode to change the bind to something else later on. But for now, if you are following through with this tutorial, it should just go straight into bind mode when you turn this on for the first time. So we're going to do that. We're going to flick the switch. We can see our LED lights up. I'm not sure if you can see, but right down the bottom there, the control board is flashing a light. That means it's waiting for a bind. So to bind, we're going to press the bind button, which is this one over here in the little black circle. Press the bind button and power the controller up. Make sure that all of our switches are in the right thing. The screen flashed up saying binding okay. It then made a sound and everything is now connected. On here, I am now getting a transmitter battery power, a receiver battery power, and information from the actual controller itself. Now, my controller is set up so that this is throttle on channel 3, which we do not have connected. This side to side, we also don't have connected. That will come out of these wires that go to our lifter motor in a minute. And then this final one here is our drive. So when I push this, we should see and hear the motors start to spin, which is good. That is exactly what we want. But of course, right now, we can't really tell what's happening. So I have a trick to work out which way the motors are actually spinning. And to do that, I'm going to first turn this off. We're going to turn everything off for the moment. It's always better to keep a robot turned off when you're working on it. And my trick here is tape. So I'm going to take a little piece of tape. Well, this is a rather large piece of tape. And I'm just going to stick it to the flat of the motor shaft. This gives me a little flag, and I'm going to do this on both of these motors, like so. This now gives me a little flag to tell me the direction that the motor is turning. So all I need to do is now turn my robot back on. I'm then going to turn the controller back on. And if I push up on the stick, I should see both of these motors driving forwards. If I don't, we need to correct that. And I do in fact see both of them going forwards. Now I'm going to push backwards and see if they both go backwards. All right, so that was forwards and backwards, correct? Now let's take a look at going right. So if I pull the stick to the right here, the right motor starts going backwards first, and then the left motor starts going backwards. Okay, that's incorrect. Let's try the other direction. Yeah, if we go left, the right motor goes forwards, and then the left motor goes forwards. So that is incorrect. It's possible that this control board currently has mixing enabled, which we do not want. So I'm going to turn everything off. So I've turned everything off. I'm now going to fish this board back out of here so that we can see what's going on a little bit better and see the light that sits on this board a little bit better. I'm then going to turn just the robot on, and we're going to wait. And we're going to wait until this board starts to flash. Okay, so here we go. We can see right down the bottom here, there is that light flashing. That means that the control board is now in configuration mode, and we can turn on our controller again. At this point, you do not want to move any of the sticks because the sticks are going to force it out of this mode that it's currently in. What we want is this switch up the top left-hand corner of the controller. This is our channel 5 switch. And by flicking it on and off a set number of times, we can change configuration settings in the board itself. I'm going to leave a link down below to the documentation for this. So in my case here, I want to disable or enable mixing, which I think the mixing is on, so I want to try and disable it, which means I need to toggle this switch down and back up 6 times. So 1, 2, 3, 4, 5, 6. And then the light should blink the same number of times as you flick the switch to confirm that you have done the thing that you wanted to do. And in my case, it does seem to have worked. Now, touching the stick takes the board out of that configuration mode and is now back into a drive mode. So we can look at, again, how our drive is actually situated, because now it's all changed because we don't have the mixing involved. Also, to confirm everything, I'm just going to turn off all of my stuff, turn the robot back on, and turn the controller on. So now, again, we are going to do what we did before, which is to push the throttle up and see which way the motors move. So if I push the throttle up, I get the left motor going forwards and the right motor going backwards. If I push the throttle down, I get the left motor going backwards and the right motor going forward. So it seems like this motor is currently inverted, but let's check that by going to the right. If I go to the right, then both motors seem to go backwards. And if I go to the left, both motors seem to go forwards. So at this point, it looks like this motor is inverted. So all I need to do is swap the 2 plugs on those around. And that's as simple as turning everything off, grabbing hold of the 2 purple wires, unplugging them, and then plugging them in the other sides, like so. Now, if we turn everything back on, we should have, when we drive forwards, both motors going forwards. When we drive backwards, both motors going backwards. We drive to the right. Ah, interesting. That would be driving to the left, not to the right when we push right on the stick. Which means that these motors are actually inverted. So now what I'm going to do is I'm going to power everything off again. I'm going to unplug the purple and blues and I'm going to swap them. So blue from the motor into purple from the controller and purple motor into the blue from the controller. And then of course we're going to have to go through and make sure both of these motors are plugged in the correct orientation again. But this time at least they should be correctly left and right. So again, we're plugging blue from the board into purple from the motor and purple from the board into blue from the motor. Do not know if I got those back to front or not, or why those color schemes didn't end up being the right way around, but that's fine. This is why we use plugs, so we can very quickly and easily change this without having to unsolder and resolder all of these connections, because as you could see, we'd be up to 6 solder swaps already instead of just undoing and redoing plugs. So now we're going to turn everything back on and see where we're sitting at. So again, forwards. All right, this time we have the right motor going forwards and the left motor going backwards. Again, if we go backwards, they are not the right way around. If we go to the right, then the right motor goes backwards. That's what we want to see. So that means that this right motor is actually now on the right. And if we go to the left, then it goes forwards. Okay, so I think it's just this left motor that the plugs need to be flipped around a different way. So again, turn everything off and take the plugs from the left motor, which is the purple plugs on the board, blue plugs on the motor, and swap them so that we plug them round the other way. This changes the direction of the motor. Now we should have a fully working setup. So for the final time, turn everything on. Up on the joystick makes both motors go forwards. Down on the joystick makes both motors go backwards. Right makes the right wheel go backwards and the left wheel go forwards, which turns to the right. And left does the inverse. Okay, our drive system will now work. So I'm just going to pack all of this wiring back into the robot a little more neatly, and then we can look at the lid. Also turn everything off. So we're going to remove the tape from here because we don't need this tape anymore. If you want to, you can use some of this tape and wrap it around these connections that you've just made to ensure that they stay together, and also that you know that these are the correct orientation for all of these plugs. I'll do that sometimes, not all the time. It does make the robot survive a little bit better in combat though, just because it means that none of the plugs can get unplugged in a big hit or something like that. From here, we're going to work on the lid. So first of all, I'm going to plug in the weapon motor. Because it is forwards and backwards, you're going to do this with the side to side on your stick. So it doesn't actually matter which way round these go in. It's just a personal preference for if you like lifting being left or lifting being right on that particular stick. Now we've got those plugged in, we might as well put the wheels on as well. So the wheels have a D-shaft hole in them. You just need to line up the flat of the actual motor shaft to the flat of the D-shaft hole and push. It's going to be a little bit tight. That's good. You want it to be tight because otherwise the wheel is going to come off. And there we go. Just like that, we've got one wheel on and we'll put the other one on as well. Again, lining up the flat with the flat in the wheel and push. Like so. And done. So now it's time for our lid and our weapon. So we're going to put the weapon together first. So we take our lifter arm and jam it into the gap in the lifter forks down here. You should see that there are some bolt holes here. We now want to take two of our bolts and screw them in. Now these you are screwing directly into the plastic and kind of forcing threads through. This is why you want a nice big handle on your screwdriver, because you need to be able to put a decent amount of torque into these parts and just thread this all the way through. This is going to take a little bit of effort and a little bit of force to do, but you should be able to just force this screw all the way through. And we're going to want to do this from both sides. So I've done this one from this side, and then I'm going to take another screw and I'm going to do it from the other side. Of course, I actually want to put these all the way down in here in a second, but I'm just getting them partially in for the camera so you can see what I'm doing, and then I'll finish this off camera because you don't want to see a minute of me pushing a screw through a hole. Those screws are started now. They should self-align as you keep going. You can also kind of force them around a little bit, especially with the head of your screwdriver in there, just to get them to be where they need to be. If you have any trouble with these, or the plastic cracks, or you can't get the screw all the way through, the other thing you can do is get the screw partially in, then just add a bunch of hot glue to this as well. It should hold together pretty well like this, and especially if you put some hot glue on the screws themselves, or in anywhere that you've made a crack, it will hold itself together. This is obviously not the ideal solution to this problem, but hot glue solves a lot of problems, especially in the combat robot world. And look, you're probably going to end up with hot glue all over the robot anyway. Then we're going to prep the lid. So the lid has these two holes, which are for the lifter motor mount, which is this particular one here. And these two holes are just slightly undersized so that, again, you tap a screw into them. It's going to be easier to tap the screw into them without anything in there. So I'm just going to take a screw, push it down onto that hole, and screw it in. Now, if you can't get the screw to start, one of the tips that I've found is to take your screwdriver, put it in the hole, and just run it back and forth a little bit. That'll create a chamfer, which will center the screw and allow you to push the screw in to get it started and get it threading. You will end up with some plastic gunk on the tip of your screwdriver, which you'll need to wipe back off again. So then all you're going to do is you're going to put the screw down into the hole. I prefer to do this with what I'm trying to thread flat, because then I can put a lot of pressure on the actual screw head to try and keep it straight up and down, and hold it nice and straight. And then just start screwing in. Now, jumps all over the place. You may need your fingers to support, but once you get it going, it should self-align. And now I'm just forcing this screw into the plastic, just like this. And that is forming a thread in this plastic. You will get a little bit of plastic gump out the bottom as well. This is where threads are being cut in this plastic. I haven't got this aligned perfectly, but it doesn't matter too much because the motor mount that we're going to use here in a second should allow for this to happen. And you can see I've got some more gump out the bottom and my screw just poking out the bottom there. So of course I need to do this on both sides. So that's one done. And we'll now do the other. Again, I can really just force this screw into here, cutting these threads. And then again, I'm going to get some plastic out the bottom, and again, I'll get my screw out through the bottom. And just like that, our lid is now ready for use. And put the lid on by lining this up so that this little slot here sits near where the switch is. We're going to make sure that our battery connector pushes down. Our motor wires come over to this side because our motor needs to come up, and that slot there is for those motor wires to sit up through, just like this. With that done, we then need to put in the 4 screws that hold the lid down. So these 4 screws go into each of these and sit into those hex nuts that we put in earlier, which was why it was important that those were tightened down, so that when we get to this step, we don't need to worry about grabbing them because they are held tight to the robot already. So we should just be able to put a screw into all 4 of these holes. Might take a second to line up the hex nut on the inside, but once you've got it, the bolt should screw down nice and easily. And again for the 3rd one, and again for the 4th one. They should just self-center in on those hex nuts. Now you don't want to over tighten these because otherwise you will bend the top plate. A little bit of bend is fine, but overdoing it and you'll see that these corners really start to lift. That's not a good thing. And then with that done, all we need to do now is to finish off the actual lifting system. So the easy way to do this, again, there are some locating features inside. We're going to sit the motor down such that it's flat. The face is flat to the edge of the motor mount. We're going to push that down and just kind of hold it in place. And with our last 2 screws, drop those into the hole, and then they should just get screwed directly into those threads that we made before. This may be a little bit tight, but that's good because that means that your motor mount will hold down really well. We're just going to tighten this one down. Now again, we're going to do one part of the way, then we're going to get the other one in before tightening them both down. This way, we know both of them actually fit and work when we tighten everything down. So here we go. Give this a good old tighten. And because this is the second one, we can just tighten this all the way down into the ground and make sure that it holds the motor in place nice and firm. Just like that. And there we go. We now have our robot mostly together. These wires poking out the side are a little bit concerning. We can poke these back into the robot a little bit better, mostly by jamming the wires inside, which is fairly easy to do with a small screwdriver. Just make them sit down a little bit nicer so they're not jamming out into the wheel. Finally, we can take our weapon and we can put it over the shaft. There is a D slot in the back of this as well, so you need to make sure that lines up with where the slot on the shaft is, and it should sit down nice and easily. Now, You can see that this is a little bit loose right now. There is a hole up here that you could put a screw into if you wanted to, but what I prefer to do is just to use some hot glue, because this way we can avoid having to screw down another screw through plastic, and also hot glue will hold it for a minute, maybe a little bit longer, but it's fairly easy to remove and replace again later on. So all I'm going to do is I'm going to fill up the top hole and the back with a little bit of hot glue, and I'm just going to wait for that to set, because that should hold it firmly enough onto the motor shaft without basically having it permanently stuck into that position. And then here we are with a completed robot, which if I turn this on, I can then drive around and lift the weapon arm up and down, which is all it really needs to do. So that now is a completed robot. This weighs just under 150 grams, so there is a little bit of space if you want to play around, add some decoration, some googly eyes, some paint or something along those lines. Although a color change would be better by printing the chassis in the colors that you want the parts, just because paint often adds a lot more weight than you give it any credit for. But there you go, that is how to build a lifter for the 150 gram non-destructive class. Hope that everything has gone well with your build, and we see you in a future event.